Students, today we will start the new chapter of chemistry, that is solution. Most of the substance which we use in our daily life is not pure substances. For example, if we use sugar solution, salt solution, these are not pure substances. It means mostly what we use is that they are mixtures. The utility of the mixtures depends upon its composition. That is, how a mixture is important to us, it depends what is the content in it. For example, we know what we are studying. We are studying solution. We have discussed that most of the substances which we use in our daily life is mixtures, and we know the mixture is result when pure substances are mixed to it. What we know? The mixtures are a result of combining pure substances. That is element and compound. If we discuss, we know the metals are the purest substance which we use in our daily life. But in our daily life, we use metal rarely. Most of the substance which we use in our daily life is mixtures, and the mixtures are result of mixing of pure substances. We know the pure substances are compounds and elements. It means when we mix element and compounds, it results into mixtures. But the utility of the mixtures depend upon its composition. Let us see how a mixture is important. Suppose we know the next one, brass. Brass is a mixture of copper and zinc. Brass is important to us because of its property, and the property of the brass is dependent upon its composition, that is the copper and the zinc. That's why the brass is important to us. It means the utility of the brass depends upon its composition, that is the amount of copper and zinc content in it. Next to that, we will discuss about the German silver. It is a mixture of, German silver is a mixture of copper, zinc and nickel. To the next one. The next one, bronze. Bronze is a mixture of copper and tin. Here we have various examples by which we can know the utility of the mixtures depends upon its composition. The property of the German silver is dependent upon its composition, that is copper, zinc and nickel. The property of the bronze is dependent upon its composition, that is copper and tin. It means how a mixture is important to us, it will depend upon its composition. To the next, we will discuss that in case of toothpaste, the concentration of fluoride ion up to 1 ppm is beneficial to us. Whereas if the concentration of fluoride ion is greater than 1.5 ppm, then it will lead to malting of the teeth. This is how the toothpaste is a mixture, but its composition, that is the content of fluoride ion in the toothpaste, is going to control its property. It will decide whether it is useful or harmful to us. The next one is the concentration of fluoride ion in our toothpaste up to 1 ppm is beneficial. But higher concentration greater than 1.5 ppm leads to malting of teeth. The next, the higher concentration of fluoride ion, it is also used in rat poison. This is how what we see, that the concentration of fluoride ion up to a certain level, that is 1 ppm, is beneficial to us in a mixture, whereas the higher concentration of fluoride ion in a mixture is harmful to us. The next what we have, higher concentration of fluoride ion is used in rat poison. For example, sodium fluoride is used as rat poison. The next one, the intravenous injections which is given to us. Intravenous injections, the solution which is provided to us in the form of injection, it has the same concentration to that of our blood. If it has not the same concentration, then it will lead to dilution or concentration of the blood that will lead to fatal effect. How it is fatal? If the concentration, on giving intravenous injection, if the concentration of the solute in the blood increases, then it will lead to shrinking of the blood cells. Whereas if it is dilute, it means the concentration of salt in the injection is lesser, then it will lead to swelling of the blood cells. That's why the injections which is provided to us should have the same concentration to that of the plasma in the blood. Otherwise, it will lead to crenation, or we can say it will lead to crenation or shrinkage of the blood vessels or bursting of the cells. The next point what we have, the intravenous injection given to us should have the same concentration to that of our blood. These are the various experiences from our life from which we can know the utility of the mixtures depends upon its concentration. We know the brass is a mixture of copper and zinc. General silver is a mixture of copper, zinc and nickel. Bronze is a mixture of copper and tin. The concentration of fluoride ion in our toothpaste up to 1 ppm is beneficial, but higher concentration greater than 1.5 ppm lead to margining of the teeth. Higher concentration of fluoride ion is used as poison, such as sodium chloride is used as rat poison. The intravenous injections which is provided to us should have the same concentration to that of our blood. Otherwise, it will lead to dilution or concentration of the blood, which is fatal to us. This is how what we know the solution. The solution is important to us, and the mixtures, the utility of the mixtures depends upon its composition, on which its property is dependent. Let us discuss the next topic, that is the type of solution. Type of solution. But before that, we will discuss what is solution. A solution which we are discussing here, it is a homogeneous mixture of two or more than two components. It should contain two components in case of binary mixtures, whereas it may contain greater than two components. It means how we can define solution, that the solution is a homogeneous mixture. Homo, it means the distribution is uniform throughout the mixtures, that why it is termed as homogeneous mixtures. Let us discuss solution. It is a homogeneous mixture of two or more than two components. You know, homogeneous, as the name indicates, homo means it has uniform distribution. It has uniform distribution. Uniform means if we have a sugar-water solution, then on mixing sugar into it, it has a uniform distribution. If we are going to test the droplets of water from anywhere in the mixtures, then it is equally sweet. It is equally sweet because on dissolution of sugar, the sugar is uniformly distributed. That is why we termed it as homogeneous. And mixtures, we know it is a type of physical association. This is a type of physical association in which the individual component retain their property. We have already discussed the property of the mixtures. So what we have discussed, that the solution, it is a homogeneous mixture of two or more than two components. What is binary mixtures? Binary mixture, as the name indicates, binary, it means two. A mixture having two components is termed as binary mixtures. It means a mixture that contain two components termed as binary mixture. In this chapter, we will concern with the property of only binary mixtures. The next thing is that we will know what is solute, what is solvent, what is solution. Let us see. If we have a beaker, in that beaker we have some water into it, and we add 1 to 2 teaspoons of sugar. Then the resultant, what we have, is known as mixture, or we can say it as solution. And this solution of sugar into water, it is type of homogeneous mixtures. The sugar, which is in lesser amount, we have two components, sugar and water. Therefore, it is termed as binary mixtures. In these two components, the sugar, it is in lesser amount, and the component in the lesser amount is termed as solute. Lesser amount, and water, it is in higher amount, it is termed as solute. The sugar plus solute, lesser amount, therefore it is termed as solute, and the water, which is in higher amount, is termed as solvent. The solute plus solvent, it forms solution. What we know, the first one is solute. The component in a mixture which is in lesser amount is termed as solute. Here what we have, sugar, or it is termed as, or it is termed as dispersed phase. To the next, what is solvent? Which is in the measure amount. The component in a mixture which is in greater amount is termed as solvent, or it is known as dispersion medium. To the next, we will what we know, that the state of the solution. What is the state of the solution here? It is a liquid state. It means the state of the solution will be same as the state of the measure component. The next, the state of solution is same to that of solvent. The next point is that when the solute plus solvent they form when the solute is added to solvent. It forms solution. This is what we study. Solution, it is a homogeneous mixture. I have told you, homo means uniform. A mixture which has uniform distribution is termed as homogeneous mixtures. Binary mixtures, it means a mixture having two components. Mixture may be possible which has more than two components, but in this class we will only deal with the binary mixtures. Binary mixture, as the name indicates, pi means two. It means a mixture having two components. Here what we see an example of sugar in water. Solute we know. The component which is in lesser amount inside the mixture is termed as solute. The next, the component which is in higher amount is termed as solvent or dispersion medium. We have also discussed that the state of the solution is same as to that of solvent, that is in the component in measure amount. The next, when solute is added to solvent, it forms solution. To the next, we will discuss that the property of we will discuss the classification of solution on the basis of the dispersed phase and the dispersion medium. Based on the physical state of the solute and the solvent, our solution is categorized or classified. Let us see how a solution is categorized. It is categorized into three types: gaseous solution, liquid solution, and solid solution. If the major component is gas, if the major component is in gaseous state, or you can say if the solvent is in gaseous state, it is termed as gaseous solution. If the solvent is in solid state, it is termed as solid solution. And if the solvent is in liquid state, it is termed as liquid solution. Let us discuss it. We will discuss type of solution.